and state-of-the-art sensors and how they differ? Do they use, MOS versus electrochemical sensors? How they differ?
Right. So actually, the first thing we used sensors that were they were made from complementary metal oxide semiconductors. They're
Yes.
called MOS sensors, is what they're usually referred to as.
Yes.
And so those are widely used in the automotive industry to monitor emissions to a pretty low cost compared to, say, what a scientific instrument used by the government agencies would use.
Right.
So the problem with those is that the automotive industry is really not concerned with absolute accuracy. They're concerned with event detection when sort of an emission system fails. They want to be able to detect sort of rapid changes in the ability of a sensor to or of a filtering system to keep the emissions down. So what we learned from that initial deployment of eggs was that there was too much variability in that sensor technology to kind of give people longitudinal ideas about the pollutants. Getting a little bit of an echo there.
Right. I'm sorry, gentlemen. Venkat, could you please put on headphones, mate? Obviously, the sound from the conversation here is this feedback. So if you don't mind, sorry, gentlemen. Sorry.
Yeah, it's okay.
Go ahead.
So
Go ahead,
what we did is, in the meantime, we had been looking for alternative sensors that exhibited sort of less variability, and the other thing with the automotive sensors is they had no calibration characteristics provided by the manufacturers. So we went in search of another provider of sensors,
right.
And the two dominant ways to measure gases is through this electrical resistance phenomenon that MOS sensors exploit, and the other one is through chemical processes where they oxidize and reduce the gases on in a like an electrolyte inside of the sensor.
Right.
So the new sensors that we're using on air quality version 2 are electrochemical sensors, and the company that we're working with is called Spec Sensors, and they actually do provide some level of calibration at their factory, where they tell us sort of the response of the sensor over a span in terms of the linearity of it. Right. And then what we do here, when we get them and integrate them into our payloads, is put them into a zero gas chamber, and that lets us set the intercept of that line that describes the sensor's response.
Right.
So that's a big step up from the first version of EGG, in that the sensor manufacturer gives us a part of the calibration, and then we kind of fill in the gap of the context, that the electrical context that it gets put into.
Right.
And then all that information is cataloged so that if it ever gets lost, every egg kind of gets this put into it during grooming here, and that information's in its memory, and we catalog it so that it can be recovered later if necessary.
Right.
Yeah, so all of these types of sensors, it's actually more of a general phenomenon in sensors than just gas sensors, but all sensors have some degree of covariance with temperature and humidity. Right. And so there's some amount of compensation that we can do for temperature based on the manufacturer's recommendations, and the software has that in it. But there's a more complicated response to temperature and humidity that we would like to get a better handle on in order to compensate for it fully. So if you sort of look at the response of a temperature under, or the response of a sensor under like zero conditions, zero gas concentration conditions, and vary the temperature and humidity, you'll actually see a response that correlates to the temperature and humidity changes. And like removing that is something we ought to be able to do in software, but it's going to take more kind of work for us to figure out an adjustment to the readings that kind of compensates for it across the full span of environmental conditions, like what you were talking about in a deployment in India. It might look different than in a deployment in the desert, right?
But if I'm not mistaken, when it comes from the factory, shouldn't there be these calibration curves already built in, or do they do it for factory-specific lab conditions?
So they do it under factory-specific conditions. Yeah, they run it at like I want to say 25 Celsius and like 30% relative humidity when they give us their linearity conditions. So yeah, so the nice thing is though, every egg that we deploy also has a very high accuracy temperature and humidity sensor, which is another improvement we made over the first egg.
It's actually
yeah. So that's the here. This is the board that sort of does the sensors.
So can I talk for a second?
Yeah. Go ahead.
So the thing do you have a pen that I can point with? So the interesting thing about this sensor is that, I mean, the reason that we include a humidity and temperature sensor is because we need to do this compensation. And our temperature and humidity sensor is very accurate. It's accurate to within half a degree or even less of temperature. And you can see it. It's over there. Can you see that? Whoops.
Indeed, we can.
And so it's important. So you notice, if you can see, but there's actually a PCB cutout over there, and that's to prevent heat contamination from transmitting through the PCB itself and heating up the temperature sensor and giving you bad results. So we have this thing out in a corner, and it's isolated, and this is the unit that measures the temperature and the humidity, and we use that to provide us with calibration information for these two units. It's just a unit I happen to have lying on the table because it probably failed some test. I'm not sure why it's here.
Yeah.
So we take the temperature information, and we calibrate and we change the curves that get given to us from the sensors. And actually, I'm not aware of any other sensor in the sort of sub $1,000 range that does this. But it's pretty important because you end up with a, the temperature is changing the concentration, and if you have a constant concentration and you vary the temperature, it will appear that the concentration has changed, but in fact it hasn't. It's just the temperature response. So we compensate for that using this, and that's why it's so important to isolate the unit. And we also try to provide, I mean, one of the reasons we have a fan, and we've tried a ton of stuff with these things, but one of the reasons we have a fan is that we want to provide a known airflow with a known air changes per hour coming across the sensors, which is why the egg has this sort of weird shaped ducting with the fan out the bottom, right? So it's sucking in new air on the sides, it's pulling that across the sensors, and then it's venting it out with a fan. The fan obviously vents because the fan has a warming action itself. So that's the sort of mechanics, if you like, of how the air quality egg gets to the answers it gets to.
Right, and the great thing about it being open source is that as we learn new things about how we can compensate better for temperature and humidity, we can publish new software, and then with the new egg, we can actually promote that software to eggs over the internet automatically.
Nice. Over the air. So once the calibration curves are determined for specific conditions, those eggs can be programmed with those specific calibration curves.
Right.
Yeah. And actually, you can go on GitHub right now, and you can look at our code. I mean, it's all there, open source for you to see. If you go to GitHub Wicked Device. So that's the benefit of open source. Hopefully, we'll get people interested in contributing back to that.
Absolutely.
Now, the sensors themselves, the gas sensors themselves, are completely they're completely analog devices. So there's no intelligence on the sensors in this case. What the manufacturer gives us is they give us a QR code that's connected to each sensor. And actually, every shield, sort of, you can see, we stick the manufacturer's QR codes on the back of the shields as a kind of historic record of what sensors are on which product. And what we do is in software, we put in those parameters so that the circuitry can be configured for the sensors, and then the interpretation of the response is tailored to those parameters.
Right, right. I'm trying to understand the role of airflow with particulate matter sensors and optical counting. I understand the need to sample the same airflow each time, each sensing event. But in the case of gas sensors, clearly the more gas molecules pass by the sensors, the greater the gas count. So therefore, airflow is going to have an impact from that perspective. But you're also trying to keep it cool, are you? Generally speaking, are you trying to maintain the temperature?
I mean, we are trying to keep it cool, but also trying to keep a known flow rate moving across the sensors,
Okay.
so that we're not relying on the sort of internal heating or, I don't know, like a wind outside blowing or something like that, which would you know, what you don't want to have happen is that just because it's windy today, you get different temperature reading or different concentration of gas readings.
And you also don't want stagnation of the air in the chamber, because what'll happen is over time that'll build up and it'll appear as a growing concentration when it's in fact just a stagnant concentration.
Understood. Understood. It would seem like airflow then with both PM sensors and gas sensors is a critical part to accuracy.
Yes.
With existing with federal sensors and other devices that are expensive, they use samplers for that. Have you guys thought of doing that? I mean, how much would it add to cost? Could there be low cost, maker space samplers that could be added? Do you think?
And that's a really good question, actually. I would summarize that I don't know the answer to that. We haven't looked at it. If you want to take a little side project, and go and look at that, that'd be great.
Yeah, sure.
So I've got one of the dust sensors here as well. If you want to have a look at that.
Indeed.
So the way these things work is they have kind of a scattering chamber and an infrared LED that beams into the chamber. And then they have sort of an intake on the bottom and an outtake on the top. And they actually work based on having a resistive element inside of them that creates a convection, a heat-based convection, so that particulate matter coming past the unit is kind of drawn in through thermal effect, and then brought into the chamber where the light scattering takes place.
Indeed.
And that affects its output over time, so that you can actually measure it. But in the same way as the gas sensors, you really want to have the newest air coming through, so that you can so that the thermal effect can be sampling new information.
Exactly. Gentlemen, it would seem like Pavan, the initiator of the call, has messaged me saying that the quality of the call at his end is actually quite bad. I can hear you guys really well. It would seem like you guys can hear me as well. Would you mind if we tried restarting the Hangout to reset settings and see if it sounds better?
No problem at all.
Thank you.
Whatever works for you is fine.
Just a second, please.
Okay. Yeah. I think it can be turned off. Let's see.
I guess it's just two of us here.
It looks like it, yeah. I'm not sure if they wanted me to leave the call and come back in.
Yeah, that's what's supposed to be done.
Okay, let me cancel out of it, and I'll come back in just now.
Yeah. Oh, yeah. They just left the call and came out. They just left the call and they're coming back.
That's right, gentlemen. I'm hoping they'll sign back shortly.
Yeah, they are.
Is it better?
Can you hear us better, Pavan?
I'm back.
Yeah, it's much better now.
Got it. Good. So we'll continue then with the discussion. Vic, Dirk, can you hear us now? Can you hear us now?
I was thinking. Wait. We can hear you.
Okay, great. So okay, so
we shut the video off.
Yeah, video might be an idea.
Is it helpful if the videos?
I think we can try that as an option and see where we go to from there.
Okay.
I just need to get my video off. You're right, Dirk. Hangout is a fiddly thing. So you were saying with regards the calibration aspect, because that would, to my mind, in terms of accuracy and data completeness, be a major part to trying to achieve, at least try and achieve the QA/QC standards that the EPA have lined up for other citizen science projects. So, as you know, that the pollution control boards in India typically follow EPA standards and guidelines. So ultimately, we want to try and interest state authorities there in the work we're doing. And for that to happen, I think we need some minimal amount of QA and QC to be implemented in our data collection management process. Have you thought about that in terms of how data is collected and how it might be better collected?
I mean, yes, we've thought of that, of course. We have worked with one guy who's a retired scientist from Utah, I believe, but we don't have anything at the moment, which is the what I would call the acid test of having the eggs next to an EPA-approved sensor. We're showing that there's a high correlation. I think that's a good thing. It's something we want to strive towards. It's a good thing to have, but we don't have it now.
Understood.
There are other sort of standards that we've been looking at in terms of getting certificates made. You can actually have sort of a subset of your products go through a more rigorous certification process, and I think that to some extent those certifications
yes.
can be generalized, but the answer to it is a bigger question, right? It's a question of process up and down the chain, from where it's collected to how it's maintained to how frequently it's recertified as well. If you want to get into sort of actionable government kind of reliance on these kinds of things, and that's where a lot of the cost starts going higher.
Right.
I wonder if maybe a better model for it is to use devices like Air Quality Egg to identify locations where higher scrutiny is merited by government agencies with more expensive equipment.
Understood. Assessing and screening. But that's the point, Vic. I mean, these are expensive sensor systems that these guys deploy. Often they need to be housed in civil infrastructure. Would they trust, if I can ask the question, how will they know to trust the data unless, or to rather deploy a new federal sensor in a new area, unless we can show that the data collected is of a certain quality? Convincing them is going to be hard otherwise.
That's exactly.
So in a sense, it's a chicken and egg issue. We need to collect the data accurately first before we can convince them, and then move on from there.
Yeah, and I mean, a lot of the reason we're doing this isn't because it's easy, right? It's actually because it is a challenge, like what you're describing.
Right.
I think trust is built. I think trust is built over time.
Indeed.
I think we are. So we as like citizens are sort of responsible for conveying to our leaders that we this being just actually engaging in this kind of deployment of sensors is a way of illustrating to our leaders that we care, and I think further to that end, we are we are our government and in some way, right? We are represented by our governments. So engaging those people at decision-making levels to take this stuff more seriously is sort of all part of the mission.
Absolutely, and that the EPA has actually started, analyzing these devices and measuring how they work. I think is a solid first step.
Exactly.
We are planning to work with volunteer groups like Engineers Without Borders, India, and other groups who can actually provide the manpower required. You were mentioning how the cost of a system like this goes up significantly when you want to start to maintain QA and QC, but we're hoping to keep costs down by kind of crowdsourcing involvement. How sustainable that is in the longer term needs to be figured out. But there is interest from these groups because they're already involved with human development, and they have a focus on the environment, and they're technical as well. So I know calibrating these devices, maintaining them is not trivial, especially calibration. But I think with appropriate training from, say, a group that provides us the federal sensors, we might be able to train a small group, a core group that can go out to people's houses on a periodic basis and actually maintain these devices and recalibrate if necessary as well. Not necessarily at the person's house, but at least bring it back to the lab and then recalibrate.
Absolutely.
So
a thing of interest there is that it's not all about technology, right? It's a lot of it's about process, and a lot of it's about sort of documenting process and demonstrating the process is followed.
Exactly, Vic. And I was reading some of the EPA citizen science reports, and they have extensive templates that are available there, which we hope to modify for what we're doing as well. I'm happy to send you those documents as well if you haven't already reviewed them.
Yeah, that'd be great.
But they have QA/QC templates that have been built. I'm hoping to touch base with Ron Williams of the EPA as well, and let him know about what we're doing and figure out if he might want to be involved as well.
Absolutely.
But anyways,
we'll also be planning to kind of reach out to Ron separately, so that'll be good to get multiple angles on that.
Sure, absolutely. And now since we're talking about maintenance, with the air quality egg, I've played around with it. I love its design. How did you come up with the idea of the egg shape? What was the motivation behind that?
Idea of what?
The egg shape.
Oh, so I came up with the idea of the egg shape. We were sitting in New York City at a unit, and we just needed a name for it. The egg seemed a good shape. We were sort of discussing all the.
It was a meetup, right?
Yeah, it was a meetup. All the aspects of it, and it needs to sort of shed water. It needs to fit all the stuff inside it. And we were just shooting the breeze, a group of like 5 of us within a sort of a subgroup of this whole meetup. Yes. And we just came up with the air quality egg. It just had a lot of resonance at the time. People liked it. It really gelled. They really got excited about it. So we decided to keep the name.
Has a lot of symbolic value too.
Yeah, I mean, it's, there's
something
a lot of
something that you nurture, something that's a more personal than a cold technology.
Indeed.
Yeah, and I mean, again, there's this manufacturing constraint, so we try to do it all relatively cheaply in a way, that puts a lot of constraints on what you can and can't manufacture. And the egg is a nice round shape that we think works well, and it's pretty, pretty fun.
Absolutely, it's a friendly shape as well. And you encourage people to open it up and actually have a look around? Is that part of the design philosophy?
I mean, we certainly encourage people who feel competent enough to do that to do it. I mean, I wouldn't say, we sort of leave it up to the individual to decide if they're sufficiently competent to open it up and take a look. I mean, we've added a lot of things in the version 2, although it's the same enclosure. We've added a lot of things. You have got the sort of capacitance button or touch sensor that you can use. It's got the LCD panel. So there is more in there. And if you don't know what you're doing, then by all means you'll probably break something. But I think that for people who are into this and into open source, there is a lot you can do. But there's also a lot you can do without opening it. The new version 2 egg has a primitive terminal, so you can interact with the egg. You can have a look at the settings. You can go to the Air Quality Egg website and scroll down, and there's a serial terminal on the airqualityegg.com homepage that you can connect to. I mean, you can also connect with any serial package. And you can look at it, you can see the configurations that your egg has. You can do things like change reporting from Celsius to Fahrenheit. You can change all the metrics. You can, there's a lot of things you can do just through the terminal interface of the egg.
Yeah, it's vastly more configurable.
Understood.
I think it's got. I think there's a heritage in the air quality egg of coming from a DIY and maker community, and so the fact that it's all open source and even down to the hardware and the software is certainly, I think, certainly encouraging to people that have that leaning. But we've gone along, we've gone a long way to try and make it more accessible to a broader audience, so that we can keep that DIY kind of heart that's to the egg, and also allow it to be usable by people that don't have that that skill set.
Yeah,
understood.
I mean, I would say that. I mean, Saram, if you sort of look on the spectrum from people who just want to get data on their cell phone to people who are experts on air quality, I mean, I would definitely say that you are more on the expert side. I mean, you know a lot about the subject. You know far more than the average person in the street who might purchase an air quality egg knows about air quality in general and about the air quality egg specifically. So I would say, I mean, you would be in a much better position to extract sort of value out of a terminal interface or opening it up than 99% of the people who are going to buy this product who just want to, see their air quality, and that's a completely fine place to be. All you want to do is, get the product, plug it in, and see your air quality. That's great.
Right. I'd love to, as we talk on this. So we have two major applications that we see for the AQE. One is placing them near major traffic hotspots, because standing traffic is a major contributor to PM and NO2.
Yep.
We want to try and adapt the egg for semi-outdoor to outdoor conditions. And the other one is placing them in people's houses in a neighborhood which is surrounded by thermal power plants. And as obviously NO2 levels go up significantly. They've been, according to NGO there that we're working with, respiratory infections have gone up through the roof. They're very keen to figure out a way to pick up data about NO2 and PM levels that would allow them to advocate and lobby on behalf of the affected residents.
Right.
Good. That's the perfect use case.
Indeed. Now, with the AQE, we'd like to be able to mount them to a wall. So mounting holes become something that's central and necessary, because we're planning to do semi-outdoor, say under a roof eave. How do we modify the enclosure? If we were to literally drill holes into the enclosure, would that affect readings? And sealants and obviously ingress of air and water become issues. What do you think?
So can I talk a bit?
Yeah.
Okay, so we've thought about this a little bit. Let me first answer your direct question and then answer the bigger question.
Right.
So the enclosure is made of a plastic called Marlex, M-A-R-L-E-X.
Okay.
Soft, malleable plastic that injects nicely. You certainly can drill holes in it very, very easily. Honestly, you could probably just put a screw in it without drilling a hole.
Yeah, or mill it.
Yeah, or mill it.
Right.
So I don't think that's difficult. And there is that string hole at the top where you can hang it from a little bit of string. That's what the holes at the top there go for.
Right. Interesting.
Having said that, I think that another way to go might be to 3D print a frame, if you like, for it to sit into, so it can sit sort of upright in a frame, and you can easily 3D print a piece so that you could sort of clip it into a housing on the wall rather than having the egg itself be screwed into the wall. You could screw the housing or screw the cradle onto the wall, and then just put the egg in the cradle, and that would allow you to move it around easily.
I see your point. So use
and I guess another.
Right. Yeah, go ahead, Vic.
Yeah, another point to make is that the enclosure itself is also open source. You can get the 3D design files for it for Rhino 3D,
Nice.
and if you had access to 3D printing, which many maker spaces do, it is 3D printable. So like initial enclosure were all 3D printed.
Right.
Now you need a fairly good quality 3D print in order for them to fit together well, but
Right.
doable.
Yeah.
Absolutely.
I would actually say that a really fun makerspace project to contribute to the air quality egg movement would be to print up a cradle or an enclosure to wall mount it.
Yeah.
That's a good idea, because they need to be generally away from, for free flow, they need to be away from walls and other civil structures, don't they?
Yeah, and the fact that we have a forced air sort of solution to the airflow with a fan means that any openings you make, so long as they don't become dominant openings over the existing airflow, shouldn't have major impacts to the performance of it. If you start making large openings that compete with the side channels of the enclosure, now you start becoming competitive with the design, right?
Yeah,
agreed.
Yeah, that's not good.
That's true. It would disturb you. It'd go from a laminar kind of condition to one that was random in terms of airflow.
Yeah, exactly. It'd either be turbulent or it would just short circuit it entirely and just not draw air across the sensors at all. And you'd be relying on this, as you say, this turbulence to get air to the sensor. But I think in terms of 3D printing a cradle or hanging it by a piece of string from a little hook or something, I mean, those are all good answers and all easy ways to solve it. In terms of placing the unit outside,
yes,
our envisioning of that has been the little weather stations around here have these little white boxes with slats in them that equipment is put into. You've got the rain gauge outside, and you've got your little white box with some other stuff inside. Your relative humidity measure, usually, so that it's not exposed to the atmosphere. I mean, you don't want your relative humidity gauge to be, in the rain. And then, putting it in that or hanging it as a piece of string just under the eaves of a house, so that it's protected from direct precipitation is really all you need.
Understood. And what about sunlight? Because temperature, you were mentioning temperature is an issue. Ambient light with PM sensors is obviously an issue, but with gas sensors, it's more the temperature increases. Would a larger fan be the solution, you think, or
not really? We don't have a good answer other than to say it should be in the shade. I think that direct sunlight, I mean, it is white. It's a white enclosure, which will help. We have actually had a black enclosure made, and the black enclosure is much, much more temperature responsive than the white enclosure.
Good idea. Yeah.
But on the other hand, I think shade is really the use case, because if it is in the sun, there's just no way to get around the fact that it's going to heat up a little bit.
Yeah, you want your sensors to be experiencing the least temperature variation possible, and putting them in direct sunlight. Gives that, not just for the sensors, but for the mix. Sounds like someone's got a bandsaw going.
Indeed. That is my fault. We're doing some renovation work at home, so.
So what I was saying is that you're going to get bigger thermal swings if it's in direct sunlight, right? So that has impacts not just to sensor readings. It can also have impacts to sort of mechanical stresses that go along with that. So just as a general rule, electronics want to see the smallest possible swings in temperature for their lifetime, for kind of making them survive over longer periods of time without feeling mechanical stresses due to thermal impacts and things like that.
Understood. And your move from MOSs to electrochemical sensors was driven partly by that, the fact that MOSs were more sensitive to RH and temperature, or was it because of the inherent deficiencies in MOSs?
I think it's twofold. I think it's firstly that they have a more pronounced effect based on temperature and humidity, but also because it's just not plausible to find calibrated MOS sensors. So the job of calibrating MOS sensors is far harder than the job of calibrating electrochemicals.
Understood.
We had the activists to use intensive sensor technology results.
Right. And also, finally, in terms of community organizing, in terms of ways in which the sensor could be deployed. I mentioned traffic management, and obviously determining NO2 levels around thermal power plants are two of the major applications. In your mind, do you know of other groups that might be doing this, Dirk and Vix, that we can learn from?
I guess I've got sort of two answers to that. The first one is that we're really engineers, not community activists. And so, although we have ideas, I think the best ideas are going to come from the community and from people in the community like yourselves, like other folks.
Right.
I do think that monitoring traffic and monitoring dust that's raised by trucks and by power plants and things like that is a big use case. I mean, for example, when we calibrate and work with the sensors here in our office, we can tell if there is a loading bay, is that the air intake for the air conditioning is next to the loading bay.
Right.
So sort of doing this, we were kind of curious at first, why the heck is the sensor broken? And one of our staff, puzzled it out, and he said, actually, the sensor's not broken. This is really what's happening. There's a truck outside pumping, gas into the which is not a very pleasant thought, but
right.
It's how our air conditioning works. So I think those are great use cases. I think they'll continue to be the predominant use cases. I think that it's going to become more and more of an issue to compare indoor versus outdoor pollution.
Yes.
There's this assumption that the air inside your house is always cleaner than the air outside your house, but that's often not correct.
True. True.
Often your air inside your house is just stagnant and getting more and more polluted. So, I mean, I think time will tell, and we really want to look to the community to come up with innovations in this area.
Understood. Thank you for clarifying that. Absolutely. I think traffic certainly is one area that where these sensors would be very useful. We'd have to find people's houses that were close to traffic spots, and probably I think one important consideration of deployment design is to try and deploy these sensors at varying distances and heights. Would that be a fair approximation of the overall parameters to follow in deployment design?
Yes, there's been a lot of discussion in groups online where people are sort of becoming interested in the height of a sensor having the same place but a different height gives a different reading.
Right.
The focus so far has been on sensors which are the height of a person, sort of 4 to 10 feet high.
Indeed.
And I think that's always the place to start.
Right.
But I do think that's an interesting area of finding our stuff out, and let's do the study and find out what happens.
Yeah, I'm pretty excited for just the possibilities that exist with sort of the new design of the egg, because like you talked about ways that the makerspaces and community can sort of engage. Well, the power subsystem of the egg is a USB port now, right?
Okay. Yes.
So
yes.
I can conceive of I have in my mind this idea to create a USB battery pack, solar power backed kind of egg into.
Absolutely.
Oh yeah, and the other thing is the other really cool thing about what you said about the original egg could only publish to the internet using an Ethernet cable. Well, now it's Wi-Fi, and it can connect to the internet over Wi-Fi. But also, I've made it so that you can take it into an offline mode completely and put an SD card into it and have it log data not being connected to the internet at all.
Right.
And so that kind of opens up the possibility of doing all sorts of interesting things, like putting it into contexts at different heights where there's no Wi-Fi, or putting it in a car and driving it around.
Absolutely.
Putting it in a balloon with a solar power source, and seeing what the air quality looks like across space in a kind of higher atmospheric levels.
Indeed. I think the idea of going with battery operation will increase flexibility enormously, gentlemen. One thing we can do obviously is connect it to a battery pack for now and move it around based on that. But having deployment flexibility would be incredibly useful.
Yeah, absolutely. And having a data logging mode where you're not relying on Wi-Fi is a very important first step to that.
Right,
Yep.
right. Good point. Good point. In the interest of disclosure, we're also going to be working with the Airbeam and other devices just to understand how things work. And the way the Airbeam works is actually quite nice. It's housing, its enclosure, it's got battery, it's got a lithium. I don't think it uses lithium polymer. It uses a lithium-ion battery, and it has indicators for Bluetooth and battery power. Anyways, I'm not trying to do a plug for the Airbeam. Just mentioning that when you mention the battery, that would be it's got a clip as well that allows you to clip it to your belt and move around. But I'm sure you know that already. So
I mean,
yes.
that brings up a sort of another interesting thing about the physics of it, which is orientation matters for some sensors, but not for others.
Right.
So when talking about designing sort of cradles or enclosures or things like that, it's sort of important, at least for particulate, because of the convection nature of it,
right.
that it be sort of maintained in the proper posture.
Correct. Correct.
Yeah, like in terms of Airbeam and other sensors out there, I think that's great, right? Like more diversity, and we can all, especially when they're open source, if we can all learn from each other, it's only going to make a better sort of outcome for us as a society.
Is the Airbeam open source?
I believe it is, right? Is the
it is indeed. It is indeed, and they have a clever way of the enclosure itself is that of a face with the eyes, so people automatically know from a usability perspective. That's a clever thing to do. So you know how to orient it. So with the egg, of course, that's apparent too with the shape of it, with the shape of an egg. But yeah, with that's one way to kind of build in usability into the enclosure itself.
Yeah, I recall that the unit itself is open source, but their data visualization application, their phone app, is not.
Right, the aircasting. Right. There's a bunch of folks on Public Lab that are building the Open Pipe Kit, I believe. Which is exactly that, Jen. So they basically are going to create pipes that allow any sensor to talk to any system. The idea being, the data you collect is yours. You shouldn't be locked into any one system. So let's make it a cross-system kind of platform. Right. They sound like in the very early stages.
That sounds like a great goal.
Indeed, exactly. That would be very useful going forward.
All the data from the eggs today, the version 2 eggs, is being routed through a company and it's being used. So anyone with there's all sorts of APIs that are being developed there to make it, to help with analytics as well. So yeah, anything we can do to hook into Public Labs and what they're doing is cool.
Absolutely.
We've actually met some of the people too.
The open data instances of the European you're referring to, which is to make sure that data stays open.
Yep.
And they're pretty big in the open data. For our data means it's accessible, will always be open, and from then on, it's forwarded to places like Dively to visualize it.
Yeah. Exactly. Another interesting thing is we publish data to OpenSensors.io, but through that command line interface, you can actually send it to any MQTT server that you desire.
Right.
If in the future OpenSensors.io became defunct in some way, it would be plausible to redirect all the eggs to talk to some other server.
We can do that.
Right.
We can just send it.
Yep. And I think the preference would be for people to kind of interface with Open Sensors to get the data, just so that we keep maintain the sort of community data set that's unified. But it's nice to know that you have a choice in where your data goes.
Absolutely, and that's the first important step in with all these data sets around the world. Normalization between these data sets, so you have a common standard, it becomes very difficult. But this is the first step to achieving that.
Absolutely. This data aggregation, I mean, it's very important. It's something that we consider important.
Yes.
I mean, in terms of offering things, I mean, if you look at the new egg, the ability to do these updates over the air, to send updated software, plus the ability to keep data open, plus the more accurate sensors.
Right.
I mean, I think those are all moving in the right direction. You now have a product that, as we develop software improvements, we can deploy those in real time over two people's units without them. They can also, if they want to, if a person wants to step out of that process and do their own thing and send it to their own server, they can do that. So they can leverage the openness. Plus, we have these more accurate sensors and we have data standards. I think that's all good.
Absolutely. Absolutely. And they're only going to get better with time as well. So,
Yep.
Wonderful, wonderful. I believe I've taken more than enough of your time, gentlemen. It's and apologies again for the initial start, but
Not at all.
Absolutely. I'd like to mull all this over with our colleagues in India and figure out how we can approach it. I think the idea of actually building a housing for the AQE in outdoor conditions would be a great first step to figure that out and to calibrate for local conditions as well.
Absolutely.
And to publish all that back up to the community. Definitely. We'll keep you posted on developments. And with regards to the black enclosure, that sounds like a promising development. Is that all the eggs I've received so far are in the white enclosure? When do you propose having the black enclosure available?
I mean, we have a black enclosure right now. It shows the white one. We can send you a black one if you want. It's totally fine. I mean, we have them sitting in our office.
They're form factor compatible.
Yeah,
so.
it's the same. It's the same. It looks very similar in shape. It's just a different color. I mean, in terms of this conversation, I mean, thank you, Sarah. We really appreciate you giving us the opportunity to talk about. I mean, I really think that this kind of engagement is essential. I think one of the things that you're bringing, which is so important, is people with boots on the ground who can, adapt this, as you say, to local conditions and can come back to us and say, look, that's a great idea, but in fact we need A, B, and C because of our local conditions. Really give us feedback. I mean, really appreciate it. Thank you so much. And please, let's keep this communication open. And this applies to other people who are also listening to this. By all means, reach out to us and open the discussion so that we can keep this going.
Absolutely, Dirk. I mean, we're not going to let you guys go because the idea is if who knows the device better than you folks, and if we're to kind of adapt, it would be wonderful to stand on the shoulder of giants, as it were. So if we could learn from you guys and keep the conversation going as we, adapt, that would be very, very useful to us, I think, as well. So
absolutely. We want to share the adaptations we have with other people.
Absolutely.
As you develop adaptations, we share them with the community. We share them with people in other countries as well.
Indeed. That would be the game plan, the longer term ambition. Wonderful. Thank you, Dirk. Thank you, Vic. It's been most enjoyable.
Thank you, Saram. It's our pleasure. Really enjoyed it.
Of course, yes.
Take care then. Bye.
Thank you.
Okay, bye.
Bye.
Yes, Sriram.
Hey, Pavan.
Yes, I think to the end it was much better. It was really smooth to listen. In the initial thing, it was really, really crappy.
Right, Pavan.
Yeah.
I don't know how much of that you gathered, but they gave us some really good ideas in terms of what we can specifically do.
No, I think the whole conversation has been recorded. I think we can revisit it. And if you want to share this conversation with the members that I have shared, so if you can go ahead and do that, I'll just give you the YouTube link in the morning.
Sure, thank you.
Sorry about my personal thing, so I was a little missing in action for a bit.
No worries. It did cause a little bit of a panic.
No, because I thought I'll be back home by 8:30, and I went to play a game, and unfortunately, it just time just ran out, and then when I looked at the clock, it was 9, and I was like, shit, and it took 20 minutes to get back.
No worries. Someone had a question. I'm sorry, guys, we didn't open up to questions earlier, but given that it was already an hour and a half, I thought it would be good to let them go. But they sounded like they're super keen to collaborate. So if there's any follow-up questions, we can certainly send them to our email. But
I think definitely we can keep bumping into them quite often now.
Well, I think they're very, very keen now. Did someone want to ask a question? Someone else? Yeah.
Me. What I wanted to know was, did they mention the fact that the readings are varying with height? This is something I was talking to Pawan, I guess, at DVAC. So I would want to know, is there a way to model this out? Because we still haven't figured out this process yet.
With height, you mean you're talking about the air beam?
Yeah, where you would want to collect data from.
That's a subsystem by itself. Deployment design. I'm talking to someone here who knows something about that. But absolutely, trying to figure out. Obviously, air quality, as you know, is going to vary based both on height and where it's located.
So what I've told Agni is we need to find different kinds of data sets with respect to different heights, kind of superimpose the data that we get as graphs and see if there's anything that the data is going to tell us to say that after a certain height, it doesn't really matter what you're measuring, you're only going to get that value. Below a certain height, you're always going to read really high values. At a particular height, between this is the sweet spot where you have to have this. So probably if we can do that kind of testing and get some data and plot some graphs, I think that should help us.
Absolutely, absolutely.
The main issue with that is we can't. Sorry, Venkat, I'll just take a minute.
Yeah, fine.
The thing is, the reason why we can't do it right now is because with one sensor, when you're taking readings, it has to be the same time zone. Like all of them have to be in the very time when one sensor was taking the reading.
Makes sense.
The problem that I'm encountering with the air beam is that the data that the data I'm getting from the air beam, I tried to plug it into my laptop, not physically plug it in, but connected it through Bluetooth and tried to read the data.
Yeah.
But the issue is the data is encrypted in some way. I cannot make sense out of what's coming out.
I see. Encrypted, did you say?
Encrypted as in, I believe it's sending the software something that's relevant to the software, but since we don't know what the software is reading, so I can't tell what data it is.
I think this question will probably be best answered by Michael when we speak to him tomorrow.
Yes.
I don't know enough about the Airbeam's guts to figure out, if it's a driver issue, who knows? It could be a fault with the Airbeam as well. But these are the questions I think he will be very, very happy to answer. The other news, Pawan, is now I have 4 Airbeams and 5 eggs all with me in Phoenix now. The air quality eggs arrived yesterday. I'm trying to figure out if I should wait for the spec in July or send this over to you guys right now. Probably send.
I think we can do a double shipment because.
Okay. The cost will remain the same more or less. But that's okay.
I think
that's okay.
Because,
Let's ship it over.
Yeah.
Sounds good. These are probably the best in class for NO2 and PM right now at this point in time. Let's start working with this and see what comes up. But an important key thing to keep in mind is that sensors vary between themselves as well, something we were discussing last time. So you're right, we should definitely place multiple eggs or multiple air beams in one location. But forget trying to look at 1 second sensing events. I mean, we've got to average it over, say, a minute or 5 or an hour or whatever. So that will be part of our research as well, to figure out how the variations change with averaging.
In fact, it was... sorry, Venkat, continue. My bad.
Okay, Sriram, I actually wanted to ask them the calibration algorithm as to how the algorithm works for them.
Okay.
Because, so that we could figure out ways for doing the testings like right now.
Let's do that. Let's do that. We'll take it offline. That's it's one of those things that little bit of a secret sauce as well. Even though it's supposed to be open source, Venkat, the calibration they tend to hold on to it because it's a difficult thing to do. And I think a lot of these guys, to be honest with you, are not entirely sure about the calibration techniques themselves, because it is something that is highly technical and requires reference quality sensors that are very expensive to acquire. So I think a lot of it is done on an ad hoc manner, and part of the reason why they're very close-chested is because they're not entirely sure whether the techniques, their processes are accurate.
I think there would be a lot of hard-coded corrections into the system.
Absolutely, absolutely. But if you're reading between the lines, Pawan, where we could add a lot of value is to do the calibration for these guys, for India, for example.
Yeah. No, and that's what we've been saying, right? So these are like the city sprints that we need to kind of find, or locality sprints, and kind of see what works for us and what doesn't.
Exactly. So in regards calibration, why don't we ask them? From what I gathered, they do they try and figure out the baseline levels. They do something called a zero gas environment. I'm not sure what that means, except what they do is they put it in entirely clean air with no gas molecules whatsoever. I don't know how they do it, but they then look at the readings of the air quality egg in a zero gas environment. And let's say it's supposed to be 0, the actual value should be 0, but it turns out to be, say, plus 10. Then that's obviously a forward biasing, so they reduce every subsequent value by minus 10. That's the overall theory at least, but you should be doing it for all kinds of concentration challenges, not just 0. But they obviously don't have the time, they don't have the resources to do that, so perhaps that's something we could try doing.
Something interesting that Josh had mentioned previously was, I believe he was talking about linear regression algorithms for machine learning. Right. So basically what he's trying to do is, at different temperatures, he might be finding out 2 different levels.
Right.
And he's trying to connect the 2 levels with whatever data he has gathered over a period of time. Possibly, I believe he's incrementing the values of the whatever sensed element in an environment. And he's trying to fit a line in between the thing to linearize the data.
Exactly.
So
exactly.
It's like
absolutely.
A feedback system, basically.
Sorry, I didn't catch that, Venkat.
It's like a feedback control system wherein each time the
exactly.
input is taken and processed, and so that you get basically a mean value of the data that might be happening.
Not a mean value. I mean, take a nonlinear equation, right? Y is equal to a plus mx plus m1x squared plus m2x cubed. X is going to be the actual reading provided by the air quality egg. And they apply the equation along with the constants that are derived from the calibration curve to come up with y. And y is the true value, or at least as close to true value as possible. So it's not a mean. They do it for each value that comes out of the air quality egg or the air beam, and then do the averaging on that for a minute or 1 hour or whatever. Hopefully the equations are linear, because that way, you're processing the floating point, your processing actually goes down. But often these equations are non-linear, which takes a lot of time, but that's what they do at the server side sometimes.
Sorry. Okay, so the thing is, these linear regression algorithms, exactly what you're talking about.
Yeah.
What can be done for non-linear systems is that you take small samples of time and you linearize it over that region. So that way you'll have small linear sets of data, like with different varying m values.
Right. Agreed. This stuff is something that requires a federal sensor that we just don't have right now, Agni.
Yes.
So we got to have relationships now. Like I said, Sri Ramachandra Medical College, the lady there has offered it. I've tried to reach out to her recently. She's, I think, been busy in the transition from the US to India. I'm hoping that her initial pledge she'll uphold. They will be the experts. They've done this. They do this as their bread and butter. I'm hoping to say, would you do this pro bono for us? But ultimately, I don't know if this is something we can. Ultimately, I'd like to move it in-house. But right now, we have to depend on other people to tell us how to do it. That said, there's some reports that have been published by PhD candidates here who have talked about this, about regression and the rest of it. I'll send that to you, so you have a better idea of how it actually works. But your idea is a good one. If you non-linearize over a small space and time, you can eventually linearize it, as long as the spaces are small enough, right? If you go too far.
Yes.
But how do you determine what those spaces are? I mean, is it going to be every 10 sample points, every 20? I don't know enough about that to understand how to do it best.
I've taken up a course in machine learning to find that out. So hopefully we'll have it by the end of the week.
Great. That would be nice. That'd be nice. So I realize it's 11:30 for you guys, so I'm not gonna take any more of your time, but I'll send off an email with an update.
Perfect. So I think it was all recorded till now. So I hope it will be good for others to also go through this.
I'll send it off to the others on the list, Pavan. Have you heard back from any of you guys? Look, I wanted sending out a general email saying please doodle up and the rest of it. I would ignore too, but there seem to be a lot of other folks on the list that could really add some value. I'm assuming if they haven't responded, they're not interested or just don't like broadcast emails going out to them. I understand that too. Would it be a good idea for me to touch base with them individually, like Gaurang or?
Yeah, I think individually it would be good to just do a quick show of hands and say at what phase you want to be, coming in or whatever. So just get a yay or nay from them.
Understood. I thought what we could do initially is just get familiar with all of these different devices first, which is what we're doing, how it works, and then we can start to look at where each one can plug in. Since they aren't involved with these discussions, interest might be a little bit dim until they have a clear plan, and until we can tell them where we want them to be involved. Obviously, if it's going to be voluntary, then they have to kind of indicate an interest in that. But maybe we can say these are the areas we need help in. Who wants to put their hands up for these areas?
I think that would make it much better.
Okay, so we'll figure out the pain points. Let's have this chat with Michael tomorrow. Then we'll have a power between us and figure out what the pain points are with all these devices. Is there one or two common things we can work on that would be useful for all these devices? Or do we look at certain things that would be useful for only one device? I don't know, something to think about. Did you hear that thing about the 3D printing of the cradle, Pawan?
Yes, I did. I did hear that. So I think that would be a very interesting thing to try out. Did they say that they already have something like that?
No, they have. So what they've said is the shape files, the 3D files are all open source. He says anyone with software. Yeah.
So which platform did they say we could take it
I think it's on GitHub. It's on GitHub.
GitHub is for coding, not for STL files.
Then it might be. I'll find out.
It might be.
It would either be on Shapeways or it would be on the other platform. It's in my mind.
Yeah, I know which one you're talking about. Yeah, I'll find out. I'll find out where it is, and if we can modify the files and build one, that would be awesome too. That's something to think about. Yep.
Sure.
Sounds good. I'll follow up with an email then.
All right. So let me stop broadcasting now, and I think we can say. I think we can close the call. Yeah.
Done. Sounds good. Thank you.